We're group 15, and we were assigned problem 64 from chapter 9 in the textbook, which deals with virtual work of a frame. The objective of this problem is to find the horizontal displacement in point C. My name's Adriana, and I'm going to be solving for the moment equations of the real frame. We'll start off by solving for the unknown reactions at A. We have a fixed support at A, which means we have a horizontal and vertical reaction as well as a moment. To solve for the moment at A, we're going to take this 804-pound force and multiply it by a distance of 5 feet. We're going to add that to 600 pounds multiplied by 6 feet. And then we're going to add the moment at point C, which is 1,200 pound-feet, in a counterclockwise direction. This gives us a negative moment of 8,800 pound-feet at A, which is 8,800 pound-feet in a clockwise direction. Next, we're going to solve for A of x and A of y. We're going to take the sum of the forces in the vertical direction, and we're going to get 600 pounds pointing upwards. When we do that for the horizontal reaction, we're going to get A of x is 800 pounds to the right. Now that we've solved for all three of these, we're going to go ahead and put this in our frame with 800 pounds, 600 pounds, in a moment of 8,800 pound-feet. Now we're ready to begin solving for the moment equations of the real frame. We're going to have to make 3 cuts. Our first cut is going to be done between points C and B, and we're going to be solving for this internal moment, which we labeled as D. Again, similarly to what we did before, we're going to go ahead and solve for the moments. We're going to have this 1,200 pound-foot moment, and we're going to add that to the 600 pound force multiplied by a distance of x1. Our internal moment equation is then 1,200 pound-feet plus 600 pounds times x1. For our second moment equation, we're going to make a cut between point B and this 800 pound force, giving us a moment equation for the internal moment, which we labeled as point E. Similarly, we're going to take this 1,200 pound-foot force moment, and we're going to add it to 600 multiplied by 6 feet. This gives us an internal moment of 4,800 pound-foot. For our third equation, we're going to make our third cut between this 800 pound force and point A, solving for the internal moment at F. Again, we have the similar moment, which is 1,200 pound-feet. We're going to add that to 600 multiplied by a horizontal distance of 6 feet. And then finally, we have this 800 pound force, which we're going to multiply by a distance of x3. This gives our last moment equation as 4,800 pound-feet plus 800 x3. Now we've solved for all 3 of our moment equations for the real frame. I'm going to turn it over to Chris, who's going to do something similar, but solving for the moment equations for the virtual frame.